Hello class, this is Ms. Hernandez, and we're going to be covering Chapter 2, Lesson 3, Translating Between Tables and Expressions. So within this lesson, you're going to learn to write expressions for tables and sequences. Have we already covered tables and sequences? Yes, we have in Chapter 1, but now we are going to add in expressions. That's right, algebraic expressions. So let's look at this table. The directions say write an expression for the missing value in the table. This right here, where I'm circling, is the missing value. So let's see. Spike's age says 2, 3, 4, then the letter A. There's our variable. Rusty's age says 6, 7, and 8. So we need to think about what the differences are between the numbers that we see going across in the row. So what's the difference between 2 and 6? Yes, it's plus 4. But is that the same for 3 to 7? Yes. What about what's the difference between 4 and 8? Yes, it is also plus 4. So if 2 plus 4 is equal to 6, 3 plus 4 is equal to 7, and 4 plus 4 is equal to 8, how would we write an expression? Let's look at what's common here, plus 4. So we would write A plus 4 in our missing value. In that way, if later on we get a question that says, if Spike's age is 10, how old is Rusty? Well, we'll know he's 14 because if Spike's age is A, it doesn't matter how old Spike is, we're always going to know what Rusty's age is because we have an expression, and it's going to be A plus 4. Let's check out another one. Ty's age, 1, 2, 3, and A. Rich's age, 7, 14, and 21. We'll take a moment, pause the video if you need to, but look and see what the differences are. Do you see a pattern? And this is definitely a guess and check. So what is the difference between 1 and 7? Is that the same difference between 2 and 14? No, it's not. So let's look at 7, 14, and 21. Those are all multiples of 7. So what about 1 times 7? Yes, that equals 7. What about 2 times 7? Yes, that equals 14. 3 times 7? That equals 21. Well, guess what? We have our pattern. A times 7, which we are not going to put the x in there, right? So please excuse this slide. It should be 7a, or you could have a with the dot and then 7. So write an expression for the sequence in the table. So let's look at the position at the top. 1, 2, 3, 4, and the letter N. There's our variable. The value at the bottom says 7, 10, 13, 16, and then we have the blank square where we need to write our expression. So first we need to look at the relationship between the positions and the values of the terms in the sequence. Use the guess and check method. So I'm going to guess 7n over there in red. So 7 times n, which would be all of the numbers that are in the top row for the position. So 7 times 1 is 7. Well, that works. But let's try the next position. 7 times 2. Well, that's not 10, so I know that that one's not going to work. So we can go ahead and cross that one off. What about 3n plus 4? Well, let's try that. 3 times 2 plus 4. Well, 3 times 2 is 6, plus 4, that does equal 10. Well, let's try another one though, because we need to make sure that it works for the entire sequence. And pause this video if you need to. 3 times 3 is 9, plus 4, that's 13. 3 times 4 plus 4, yeah, that's 16. So therefore, what is our expression? 3n plus 4. And the reason why we cannot just put that it is plus 3, because between 7 and 10 and 10 to 13 and 13 to 16, yes, it is plus 3, and that is something that a lot of you said in class. However, we need to look at the position and the value. N is the position, and we need to incorporate that. So yes, 3n plus 4. Write an expression for the sequence in the table. Position 1, 2, 3, 4, and n. N is the position. That is our variable. And the value 7, 12, 17, 22, and then we have our blank space where we need to put our expression. So pause the video and see if you can work this one out. So if you guessed and checked, you should have 5n plus 2. So 5 times 2, that is 10, plus 2, that is 12. Well, that works. Let's see if it works for the rest of them. 5 times 3 is 15, plus 2, that's 17. 5 times 4, that's 20. So then plus 2, that's 22. So I have my answer, 5n plus 2. Now look at this one. A triangle has a base of 6 inches. The table shows the area of the triangle for different heights. Write an expression that can be used to find the area in the triangle when its height is h inches. H is our variable. So the base, as we can see here in the table, is going to be 6, no matter what. And it also says it in our word problem. Our height, see 1, 2, 3, and then the letter H. Our area, 3, 6, and 9. So let's see how to work this one out. 6 times 1 is 6. But then divided by 2, that's 3. 6 times 2 is 12. Divided by 2 is 6. 6 times 3 is 18. 18 divided by 2, that's equal to 9. So what would be our expression? Well, you could write 6h divided by 2, or you can write 3h. Both of those answers will work. Now pause the video and try to work this one out on your own. I'll read the question. A triangle has a base of 4 inches. The table shows the area of the triangle for different heights. Write an expression that can be used to find the area of the triangle when its height is h inches. So just like in the last problem we did, 4 times 3 is 12. Divided by 2, that is 6. And this would be the same all the way down. So what would we write? Yes, we would write 2h. Or you can write 4h over 2. Pause the video and work this one out on your own. And when you unpause it, the answers will be on the screen. Did you get it right? Well, let's try another one. Pause the video again and work this one out. Did you get that one right? I'm sure you did. We'll relax, take a breather, and I'll see you in the next video. Bye.